Good morning, everybody. Today is Monday, April 11th, 2016. And this is Before the First Cup with Jules here on UCY.TV. Happy Monday, everybody. It is 49 degrees. Yes, it's a heat wave. And very overcast and wet here in upstate New York. Looks like we had a little rain, but the snow is all gone. Down in the southern part of the state and northern Pennsylvania, they got quite a bit of snow this weekend, but we were lucky up here. I guess Canada got it too. Right in Ontario, over the Great Lakes, they were getting some snow this weekend as well, but we didn't see much of anything short of a few flakes, and it's all gone. And in looking at AccuWeather, it looks like all the way through May, it's going to be 50s and 60s, so maybe spring has finally sprung in New York State. Yay! That would actually make my week, make my month. All right, so where do we leave off? On Friday, we titled the show AI Game Show of America for Better Citizens and DIY CRISPR Apocalypse. And remember, the DIY CRISPR Apocalypse was talking about this not-for-profit company that has been just so generously taping CRISPR kits, CRISPR E. coli, to postcards and sending them out like the Amazon of biological parts everywhere across the planet every morning, starting at 8 a.m. with interns loading up packages containing raw DNA material needed for gene editing and sending it as far away as Zimbabwe and Croatia. Everywhere. Yes, they've been sending it everywhere. And what's even more interesting is we discovered that this CRISPR bacteria that they use for editing genes can very easily be reproduced. So if they send it out to 60,000 labs, then those 60,000 labs can grow that bacteria and send it on to 60,000 more labs. We also looked, I don't know what day it was, maybe it was Thursday, maybe Wednesday, at the DIY gene editing kit. We've read about that a few times now. So, of course, was a news story about the dude in Long Island doing it in his parents' back spare bedroom or garage or whatever. They even mentioned right outside of New York City. The guy's got his own biohacker lab. Don't worry about it, though. We're going to write a cutesy little story about it in Fusion.net. Tell you how cute it is. It's pretty insane. And I'm still going to call it the CRISPR apocalypse. You know, there were stories when this technology first hit the mainstream. And honestly, guys, I know out here there's 49 tabs open in this one browser on this one machine because it crashed on me yesterday and then says, oh, would you like to reopen your 49 tabs? I was like, yes, I need them all. But shh, don't tell anybody. There must be at least 49 tabs open on all my browsers, on all my computers. So that means multiply that times 3 browsers times 4 machines and whoops. Yeah. I work my computers hard. You want to work for me as a computer, you better make sure you work hard. But there were a bunch of stories that we covered way back in the beginning even about how dangerous this CRISPR technology could be. We looked at gene drives, CRISPR-Cas9, and how they could spread traits or delete traits or replace traits in an entire population. How they could replace traits with something that could cause an entire population to become extinct in one generation. And they were experimenting in the mosquitoes. Now, there's all kinds of new Zika news I need to grasp, because I am pretty sure they're now saying it's involved with some sort of autoimmune. I don't know. Looks like they're sure spinning the big ball of shit on Zika. There are 3 different stories upstairs on my computer that I wanted to share with Dal in chat. I'll share it with everybody once I get a handle. But 3 different stories of stuff that they're now saying is causing Zika and, spinning the yarn. But then I saw Claire Bernesh had posted something this morning too. So we'll get a handle on that. But they were originally, so where we first kind of read about this CRISPR was when we were investigating the genetically modified mosquitoes. And I'm not talking about like January of this year, genetically modified mosquitoes. I'm talking last year, the year before, when we first started running into them, thinking, what? Why are they releasing these things into the wild? Looks like it's a pretty done deal. The FDA gave conditional approval for those genetically modified Franken mosquitoes down in Key West, the ones that they tried to release last year and everyone had a fit over. And now, of course, they're telling you it's for their own good because, Zika's going to kill everybody. Since not only can it apparently hide in sperm and hide in your blood and I don't know if it can hide in your joints. And now it's an autoimmune disease, and oh my God, it attacks your brain. I mean, it's like the blob. It's this thing that nobody ever researched. I mean, remember, we looked at that at the very beginning. No one ever researched it because it was such a mild virus and didn't cause any problems in anybody anywhere, really, ever. Nope. That's why they didn't even do any vaccine development or anything, because it really wasn't a virus to worry about. And then just out of the blue, poof, oh, it's this killer virus that affects all these systems. And now it's spreadable everywhere. It's spreading. I don't know. When I see stuff like that, that's one of those red alarm bells. Bing, ding, 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 ding. Somebody had it in the lab. And where do we see the one company that was developing a vaccine for this right in the very beginning happened to be out of India, funded by who? Oh, Bill and Melinda Gates Foundation. Bill and Melinda Gates Foundation, who now owns their own gene editing company, is part of, I don't know, they did some venture capitalist funding or something. But, when you see things like this, that all of a sudden something that never caused issues anywhere, really, I know that they thought maybe there was a little bit of Guillain-Barré on that one island that got infected with the Zika way back. But now there's all kinds of questions here. And all kinds of yarn spinning. And they can pretty much make Zika whatever they want. And now the U.S. is calling for hundreds of thousands, if not millions. I think it's $645 million, I think I saw, of dollars to fight Zika. The National Institute of Health and CDC are all chomping at the bit. Remember, we read also they had this huge group of 24/7 staff to deal with Zika emergencies in the United States. They were sitting there ready and waiting to respond to any U.S. emergency with Zika. What? Yeah, but you see what they're doing. They need to put this medical industrial complex that, of course, is tied in with the military industrial complex. The entire biowarfare program. If you don't believe me, go back to last year. We did a whole bunch of shows on that, tying biowarfare into vaccines and into this whole defensive posture that we're taking. Richard Nixon. I never remember the name of that agreement. We just looked it up again. I was dropping people links to that in chat. Richard Nixon, it was in 1969, originally inked, and I guess we ratified the global agreement to end chemical and biological weapons development. But what Nixon did was maintained the ability to create defensive mechanisms to protect ourselves against biowarfare in the name of vaccines. Obviously, when you're developing vaccines, you need to have the pathogen that you're trying to develop a vaccine against. And then you do all kinds of fun things with that pathogen in the lab if you have CRISPR technology. Oh, wait. And, I remember if it was last summer. I think it was last summer when we were really digging into what was going on with Zika evolving and anthrax. Remember all the anthrax that got lost? The military had shipped it to, I think it was over 100 bases. They were all over the world. the military had sent this well, they thought it was inactivated anthrax where they had irradiated it. But lo and behold, it never killed it all the way. So they had sent anthrax to labs all around the world without proper chain of commands, without proper, I don't even know what you'd call it, biohazard procedures. We found out the CDC 6 or 9 months before that had some of their own issues where there were vials of smallpox sitting around on top of filing cabinets for 30 years. Oh, not in a secure location. And no one even knew it was there. Sending Petri dishes and Ziploc baggies through FedEx. Yes, they were. So there's a lot of crazy stuff that's floating around that isn't being bagged, tagged, tracked. Like I said, this CRISPR apocalypse, we find out that they're sending this CRISPR bacteria all over the globe. They're taping it wrapped in wax paper or something. There was the DIY in the kitchen in Long Island. It arrives taped to a postcard. We found out that the CRISPR apocalypse people, what was their name? Got to make sure we advertise for them. Addgene, Addgene, good old Addgene, not for profit, thinking they're doing good. They were even sending CRISPR to China. Now, there are two things that I'm pretty worried about, and I have been for a very long time, since at least the 80s when I read The Stand. With some lunatic making something, I don't know, watch 12 Monkeys, and then letting it go like a typhoid Mary in a big city. Because no matter how much ammo and food stores and stuffs you got, there isn't going to be much you'll be able to do about something that's microscopic, airborne, traveling who knows how, with who knows what horrible consequences if you get infected. And we got mad science gone mad on every corner of the globe going on right now. In the military, hey, Plum Island, if that has to be any type of evidence. I mean, that stuff's been going on for a long time. There's a lot of people getting sick now over this last week. I don't know if friends and family of yours have gotten sick. I'm kind of battling this thing right now. Yesterday, I was starting to feel all congested. Did a little bit of silver and doubled up on my vitamin D last night before I went to bed. And I'm about halfway there. At least my nose isn't stuffed up anymore. But, you know, I know now of 6 or 7 different people in the last week in geographically diverse locations in the United States that have all gotten hit by a truck with this new upper respiratory thing that's going around. Bang! Just out of the blue. I see this morning one of the writers that I'm affiliated with posting about in California how horribly right now, with all these photos, they're getting chemtrailed. I've heard many times before from a lot of my friends down south, they get chemtrailed quite frequently. And it really has to make you wonder, you know, we talked about this a long time ago, but with all this CRISPR action that's happening, and we've read about how to get some of these different substances most efficiently into the body, and not only the body, but into the blood, across the blood-brain barrier, right? We did a lot of research into different routes into the body that scientists have been investigating, and what the most efficient route of exposure would be. We found inhalation through the small intestine would be the 2 ways, and then also edibles. All right, those were for some of those edible vaccines that we dug into. The edibles and absorbing right through into the small intestine, through the leaky gut that we've all been given. was a great way to get things into your bloodstream. But inhalation was one of the ways that they were talking about getting nanotechnology. That's always one of the big things. And I think I have 2 or 3 stories up on my notebook computer upstairs from this weekend, because normally on the weekend I work upstairs in between cutting shows. Down here, I'm here during the week. So this stuff all sits here from Friday for me to come back Sunday night late if I can make it and start closing tabs so I don't have a crash Monday morning. But the machine upstairs suffers from me pounding on it all weekend and having stories waiting for me to figure out where I'm going to put them in my queue to talk about. But inhalation was one of the ways that they had discovered, got across that blood-brain barrier, and were able to get quote-unquote medications into the brain. You know, and the brain is one of those big things that they've been researching. DARPA money sprinkled everywhere to be able to cure disease. All right, so CRISPR apocalypse. I'm going to do the beginning of this, and then we're going to continue on to Mad Science Gone Mad Day, because that's what it is. This is out of MIT Technology Review. This is where we left off on Friday. The scientific swap meet behind the gene editing boom. Gene editing technology called CRISPR is probably the fastest spreading technology in the history of biology, kind of like a virus. Here is one reason why. Each weekday at 8 a.m. at the offices of AdGene in where? Oh, Cambridge, Massachusetts. Same place that Toyota is putting their Boston Dynamics quote unquote, maybe Boston Dynamics liaison facility to work with their $1 billion artificial intelligence center in California. Now also in Ann Arbor, Michigan, they're adding another satellite and hiring some heavyweights from the University of Michigan. I found the story that Lady Pitbull had heard on the news. Anyway, each weekday at 8 a.m. at the offices of AdGene in Cambridge, Massachusetts, interns, yes, interns who have no idea what they're doing in regards to the CRISPR apocalypse, interns start loading, doing what they're told, UPS packages containing the raw DNA material needed for gene editing and sending it as far away as Zimbabwe and Croatia. AdGene is a non-profit that exists to help scientists share their DNA inventions. Think of it as an Amazon.com for biological parts. And anyone can submit one or order somebody else's DNA parts for just $65. Now, I think I talked about on this show the very first time I saw an Google ad on a website I was visiting that was for mail order DNA. And I thought I was seeing things, and I'm like, whoa, has life been so trivialized to the point where it's point and click, $29.95, and I'm ordering DNA strands online? And yeah, we talked about that. The science entrepreneur that was found dead, he was the laser printing DNA dude who wanted to democratize life creation, make it available to anyone for the right price, of course. But all you had to do was send him a sequence, and he would laser print it with precision for you and send it. And he could mass produce it like nobody's business. Or at least that was his hope, and now he is gone. Be interesting to find out who acquired that technology from his corporation now that he has departed the land of the living. Easy access to gene editing technology is what has allowed labs everywhere to get into the game. Last year, there were more than 1,300 scientific papers on CRISPR, And it has been used to do everything from curing muscular dystrophy in mice to making super muscled beagles. And yeah, we talked about that. That has already happened in China. They have also edited human embryos. And I saw a story this weekend. They have now in China edited human embryos for a second time. So it hasn't happened once now. Now it's happened twice. People, there was an interview Friday. I think it was Friday. I had some issues where I got bumped off the air at the very end of the show. And to fill space, I put in a really good interview with Jennifer Dowda, who was one of the founders of this CRISPR technology. And she had done an interview with CBS News, and they had questioned her about some things. But one of the things that they had asked her was whether or not this technology could be used to modify humans. And she's like, well, yeah, but there's laws, right? Oh, look, there's laws against this. And the interviewer, I don't remember her name, and she's just the anchor on CBS. She's like, well, yes, but there's plenty of other countries out there who aren't covered by our laws and Europe's laws. And they're like, well, that's true. And all I kept thinking was, yes, we have the CRISPR Apocalypse not-for-profit company called Adgene sending CRISPR technology to 60,000 different places around the globe. So our laws and the UK's laws of not genetically modifying humans isn't going to be helping us with anything. And like we found out last week in some of the stories that we were reading, what is fueling a lot of this mad science gone mad, driving 120 miles an hour toward the brick wall, isn't the technology of it. It is the race to who is going to break the biggest new discovery first, because that's the billion-dollar dangling carrot. So nobody cares about the consequences. It's just these dangling carrots that they're racing toward without looking at the consequences. And continue in the story. And remember those Chinese scientists who set off an ethical firestorm by editing a human embryo? Well, I'm going to add to that. Now they've done it again. They also got their CRISPR ingredients by where? Oh, mail order from Adgene, from the interns who didn't know any better. They're going to write a storybook about us someday in the future, talking about the fall of the second 21st century Roman Empire and how it all happened. I'm going to show how dumb we were, how we engineered our own destruction. Adgene was started in 2004 by a graduate student, Melinda Fan, who got tired of trying to beg and barter for key materials that she needed. Why not just create a central repository where everyone can contribute their genetic creations? Sounds very much like the repository for knowledge for artificial intelligence as well. We're just going to democratize everything, give it to everybody, because look, everybody is a good person, and we know that we could trust rogue biologists, like I said on Friday, in the Middle East, or in a back room in China funded by billionaires. This is a very, you want to talk about a Pandora's box that's been totally let out of the box. And Pandora's been genetically modified to big pointy teeth and a big slimy tail and sucks blood. It's frightening. All right, so anyway, I don't know how much more I want to read of this apocalypse, because there's more than enough to go around here. I have about 22 stories lined up for today if we can ever get there. It says if Adgene were not a not-for-profit, it would be a decent business. It actually sold $8 million worth of DNA instructions last year and banked $2 million in surplus. And Cayman says that it will invest the extra money to expand its efforts. So we're going to expand and send out more CRISPR editing kits around the globe. And along with the mad science, we discovered too that they now have 3D printers that can synthesize molecules from scratch. So, right, we talked about how you could have a chemical from a rare plant found in the roots of a little known flower in the Peruvian jungles. But don't worry about it because you don't need to get your hands on that anymore. No, all those cancer cures that are being destroyed forever as they're chopping down the rainforest. Don't worry about it, people, because we could 3D print them now using the raw materials in a lab, making synthetic versions of everything and putting it into medications. Says this machine simplifies the complex process of synthesizing chemicals into a series of generalized steps, and whether you're trying to form a ring of carbon atoms or strip away a hydrogen atom, each step requires a dose of starting chemicals, which are separated into distinct building blocks. Think of each of them as simple groups of chemical compounds like O2 or CO2 that snap together. And using this process, his machine could manufacture thousands of different chemicals in 14 distinct classes of small molecules, including known medicines to several molecules used in LEDs and solar cells. The amount of time each molecule synthesis requires is a matter of hours, depending on the numbers of steps involved. Guys, this is the beginnings of the replicator. This is the beginnings of desktop manufacturing. We're going to read a couple more stories here. It is actually really moving along the path way faster than we ever imagined, just like everything else. It says to answer the question of why such a cool technology is now becoming available, they say the hard part was figuring out how the new cleanup method that happens after each chemical reaction. They have their prototype is currently limited in the number of chemicals it can produce, but they believe that it can already be put to use in developing new drugs. And that is another story that I have here. They have a brand new 3D drug printer, of course, aiding the pharmaceutical companies. This machine can rapidly synthesize some molecules that would otherwise take a trained chemist years to craft. So chemists will be out of jobs as well in the future. And I'll tell you what, anybody who's gone to pharmacy school, I had a couple friends, actually one friend in the dorms who went to pharmacy school, and then a friend of mine years back whose wife went to pharmacy school. And I got to tell you, even a part-time pharmacy job at a place like Kmart or Walmart, and this was years back. I'm talking probably 15, 20 years back already. Part-time job you started out of school at $40,000 a year. Part-time for pharmacy. So, and I know it's hard. I remember in the dorms, the girl across the hall from me was going for it. And like she had no life whatsoever. And her dad was a pharmacist, so it's not like she could go into something else for a go-ahead hard. But I bet you she's from New York City, and I bet you anything, she's probably making bazillions of dollars now. But not if the robots get their way. 3D printed pharmaceuticals coming to a pharmacy near you. On-demand drug production is on the horizon, and this one is out of Scientific American. A continuous flow method to synthesize medicines promises to change how pharmaceuticals are produced and used. So we can genetically modify everything, and now we can 3D print pharmaceuticals out of who knows what. The prescription drug underneath that childproof cap is also often the culmination of a myriad of complex chemical reactions choreographed in huge industrial facilities on several third world nation continents across many months of time. The future, however, could look very different. Now, we've been talking, and I would have to say that if there was like an alternate title for the show, it would probably be like disruptive technologies in your face, because that's what it is. One disruptive technology changes all of history, and we are talking about hundreds, if not thousands, of disruptive technologies because of technology itself, all coming at us at the same time. They're taking the globe and turning it upside down just like you're on a roller coaster that goes up in one of those loop-de-loops, shaking us to make everything fall out of your pockets, making you dizzy so you don't know which way's up anymore. That's what's happening. And when these all start hitting, and I am seeing again, I just saw World Economic Forum discussions, 50% of all the jobs by 2020. Guys, that is 4 years from now. I know 2020 sounds like it's so far away, but it's 4 years from now. 50% of all the jobs gone because of automation in 4 years. Patients could one day potentially obtain pills from a machine that is able to take raw materials and synthesize them into drugs in a matter of hours. And what's more, the product would be not a one-size-fit-all drug, but precision medicine. Remember that? Ding, ding. A drug dose calibrated to each person's needs based on factors like age, body weight, and genetic variation that affects how one metabolizes, yes, that CYP 450 enzyme, and clears the drugs as well as takes it into account potential interactions with other medicines. Look at how they just paint, like how wonderful precision medicine is going to be for you. Give up your DNA, get into the database so we could slice and dice you and do our analytics, run an algorithm against you, plug it into the 3D printer, poof, personalized medicine. And it'll only cost you $10,000 for that pill. So now a team of chemical engineers at Massachusetts Institute of Technology, yes, another pit of lizard's den, has worked out production methods in one continuously flowing process from start to finish rather than the starts and stops of producing chemical components in a batch, often at different locations. They have hacked off-the-shelf equipment and develop new pumps, motors, heating elements, and ultrasound. Ultrasound was one of those things that also we discovered allowed them to open up that blood-brain barrier and get those drugs where they're not supposed to be. They hacked new pumps, motors, heating elements, and ultrasound to move particles around, creating a drug-producing process that is not only faster, but also more precise, more efficient, and cheaper than production methods now in use. And their work is detailed in this week's Science. The current version is a modular system where various raw elements and materials and sets of specialized reactors and processors can be plugged into different sections of the assembly. This theme of reconfigurable unit operations is really landmark, says Tyler McQuaid, program manager with who? The Defense Advanced Research Project Agency, more affectionately known as DARPA. You knew DARPA had to be involved in here somewhere. Yes, it's DARPA making on-demand build strange chemical compositions. The Pentagon's chief sponsor of technological wizardry and innovation, if that's what they want to call it, which has funded this development. Similarly, John Lewin, a pharmacist at where? Another pit of lizard's den, Johns Hopkins University, where they have the biggest database of children's brains ever. And who is also a consultant to DARPA, but not involved with the study, reviews the work and calls it simply a paradigm shift in the way pharmaceuticals are made. Guys, they are also, the fact that they are now finding easy ways to make pharmaceuticals out of mad science gone mad, and they'll be able to take all this technology, slice and dice it in any way they want, and then start putting together, quote unquote, precision medicine just for you and me. It's really a frightening thing, because we don't know what's going to be in this stuff or what they're doing. I wouldn't trust DARPA as far as I could throw them. And that isn't very far. When I think about DARPA, I think about a big clunky metal box that's loaded with all kinds of robot parts. I wouldn't be able to throw them very far at all. Don't trust DARPA ever. If there's ever anything you learned from me, don't trust DARPA. Even at this early stage of development, the synthesizer is able to produce 4 very different classes of drugs. Generic versions of the antihistamine Benadryl. Ho ho, thank goodness. Anti-anxiety drug Valium. Woo! Antidepressant Prozac and lidocaine, a local anesthetic. So how great is that? So we got an antihistamine that makes all the allergic reactions go away, at least for a little while. Puts you out cold. We got Valium. Gets rid of your anxiety when you're having reactions to whatever genetically modified insanity they've gotten into your body. Antidepressant Prozac, of course, because now you're so depressed you know that you've been poisoned by them. I'll make you some of that too. Here, take 2 of these. And then lidocaine to stop all the pain and suffering. That's frightening that they've made those 4 necessary items. Of course, they're going to tell you it's for the battlefield. At this point, the system is more than a proof of concept demonstration, but not quite a prototype that is ready to go into production. And there is still some tinkering to be done to expand its capacity to crank out different classes of drugs and wring out more efficiencies in the process. In many cases, there was no precedent for doing the chemistry in a continuous stream, and we had to develop new chemistry to accomplish that. Wow, how amazing. They developed new chemistry at MIT with the money from DARPA. They devised ways for more rapid and efficient heat transfer, a critical aspect of chemical reactions. So you have much more precise temperature controls in the reaction than with the traditional processes, right? Throw all the old 20th century, everything we did out a window because it was so dated. The current iteration of the synthesizer producing drugs in a liquid suspension, but they hope within a year to have a version tied to the 3D printer up and running so it can produce a pill of the drugs. So right now it's liquids, but they're going to be 3D printing this. Pills are often a prepared form for pharmaceuticals because they're more stable and have a longer shelf life. Those factors, however, might not matter with the capacity to produce drugs on demand. Drugs on demand. Go down the hall, honey, for a C7 and put in a $20 bill. And there's your cure. Right next to the ice machine. One reason to install the device is to ensure the continued availability of generic drugs at an affordable price. So is this how they're going to do it? Instead of farming it out. So we've talked about the generic drug problem before. Of course, there is no liability. Remember, generic drugs are done to a formulation that is quote-unquote similar. We read about that before, too. The chemical composition has to be identical. But there are issues in efficacy because there isn't any rigorous FDA testing to be done if you could show that chemically you've matched what the original patent was. We also have the TPP as part of the TPP. Pharmaceutical companies managed to get stuff written in there stating that they would be able to extend their patents on a lot of these life-saving medications. So you couldn't have third parties making generic equivalents. And those were for the new expensive 21st century drugs called biologics, remember? So instead of developing our generics in a factory in China, why don't we just make it 3D printers on demand in a vending machine? That'll get rid of any and all of the major costs involved. One reason to install the device is to ensure the continued availability of generic drugs at an affordable price. And some workhorse oncology drugs are now in short supply because manufacturers have decided that they can make more money with other products or that it isn't worthwhile for them to make required upgrades to their facilities. So, hey, you know what? Because these pharmaceutical companies aren't making drugs that are treatments for debilitating diseases because they won't make the money, we're just going to assign that to the machines. How disturbing is this? And then, of course, there's the price gouging practiced by the likes of Farmer Bro, Martin Shkreli, who purchased the rights to produce the generic drug diaphragm, whatever it is, Daraprim. The compound used to treat a rare parasite infection, which I didn't realize that you remember that. There was the dude who bought the drug, jacked the price up. Everyone was screaming, and I thought it was for something like I don't even remember what I remember reading it was for, like multiple sclerosis or something. But this is saying that the compound is used to treat the rare parasitic infection toxoplasmosis, which endangers patients with compromised immune systems. Shkreli promptly increased the price of a single pill from $13.50 to $750 because he could, and I saw now he's under investigation federally. The ability to produce these drugs on site might counter such a behavior. They believe that the synthesizer will find early use in the drug development process as an effective way to produce intermediate quantities of drugs for clinical trials necessary to gain U.S. Food and Drug Administration approval. And remember, with the 21st Century Cares Act, those clinical trials are going to be first and foremost before anyone even has to show that drugs are safe. And we have Watson, IBM's Watson. We talked about this too way back. IBM Watson is working on some sort of black box project where they have Watson scanning through the makeups of all of these on the market approved drugs already, not necessarily paying attention to what these drugs are used to treat, but paying attention to the chemical composition of the drugs to see, now using its cognitive computing, smart database, artificial intelligence, to compare and contrast the makeup of the drugs with diseases that are out there to come up with off-label uses to be able to make more money on a drug that maybe isn't being used for anything anymore. You know, maybe in the old days it was used to treat yellow toenails, but tomorrow, oh, look, we just discovered it's got similar composition to something that's used to treat, pink eye. I don't know, but so we're going to have Watson doing drug discovery and testing and things of that nature for the pharmaceutical companies and the hospitals. Now we got this 3D printer as a way to print and produce molecules, because we can already produce molecules, synthesize them out of the blue, and then 3D print them into miracle drugs funded by DARPA, working on at MIT, and put them in vending machines at low prices to cure you. Yeah, that sounds like something I want to sign up to. Traditional pharmaceutical companies will likely increasingly adapt this continuous flow method into their segments of batch processes and even maybe for the entire production of certain drugs. So let's get rid of all those Indonesians working in the generic drug factories now in Indonesia, like the $1.5 million miners in China, and 50% of all the jobs globally by 2020 replaced by robots. Guys, this is a very bad thing. I heard Nathan Fraser's pre-recorded show last night. He was having a discussion with Chris Gio and Cherie. He had been on as a guest on their show. The second half of the show, they were talking about the future potential of endless bounty with technology. Of course, Chris was on one side and Nathan was on the other. And I had read a story very much what Chris was talking about, how in the future, don't we think that it's going to be democracy for all, because the power of manufacturing will be in our hands, and what a wonderful world of bounty this will be. Plentiful bounty for everyone. So we won't have to work and we could be more creative. And Nathan had brought up the point that it isn't going to work out that way, because all of your needs will be controlled, and people who tend to not be busy tend to not be creative, but rather disruptive. And I'm going to agree with Nathan. It's kind of what the whole crux of the show has been about, is that dangling carrot promised world of Ray Kurzweil, where everything's going to be done for us and it's going to be the wonderful world of magic, 24th century synthetic everything that can be produced, poof, right before our eyes, like the replicator in Star Trek, is not going to be a world that we want to live in. Not only is it going to be all synthetic, but we're going to be bagged and tagged at a cellular level, tracked, followed, surveilled, algorithmed to see whether or not we are deviating from the norm. And if we are deviating, well, then we got a cure for that. We will be the manipulated and very closely controlled guinea pigs to a lot of this future technology. Anyway, to finish this story up, a future iteration of the synthesizer might also integrate a patient's, here we go, electronic medical health records, ding, ding, noting factors that might affect your drug metabolism and adjusting that dose to achieve an optimal effect. Your doctor would simply send the order to your pharmacy and you would pick up your personalized prescription. Or maybe they'll have your Atlas bot come deliver it right to your door. Your Google drone that's delivering medications and medevac. Rainer Martin, a medical chemist with the pharmaceutical company Roche in Switzerland, wrote an accompanying article in Science comparing the process of 3D printing pharmaceuticals with ink cartridges in a printer and the capsules used as the Nespresso coffee machine. Yes, let's explain it to dumb people. And he says it really, really opens up new avenues, new opportunities for personalized medicine. And we can all see how much money that's going to make. Cha-cha-cha-ching. All right, another story, and this one's out of phys.org. Scientists develop artificial molecules. Oh. Scientists at ETH Zurich and IBM Research in Zurich have developed a new technique that enables for the first time the manufacture of complexly structured tiny objects joined together by microspheres. The objects have a size of just a few micrometers and are produced in a modular fashion, making it possible to program their design in such a way that each component exhibits different physical properties. And after fabrication, it is also very simple to bring the micro objects into solution, and this makes the new technique substantially different from the micro 3D printing technology. With most of today's micro 3D printing technologies, objects can only be manufactured if they consist of a single material, have a uniform structure, and are attached to a surface during the production. But to prepare these micro objects, the researchers are using tiny spheres made from a polymer or a silica as their building blocks, each with a diameter of approximately 1 micrometer and have different physical properties. The scientists are then able to control the particles and arrange them in the geometry and sequences that they like. The structures that are formed occupy an interesting niche in the size scale. They are much larger than your typical chemical or biochemical molecules, but much smaller than typical objects in the macroscopic world. And with this new method, it will be possible to manufacture micro objects specific with precisely defined magnetic, non-magnetic, and differently charged areas. Currently, scientists can create very small rods of varying lengths and composition, very tiny triangles, and basic three-dimensional objects. But the researchers are keen to develop the technique further. As possible future applications, they are considering self-propelled microcarriers that move in an external electrical field thanks to their sophisticated geometry and material composition. Other possibilities include, and put on a seatbelt, micro mixers for lab-on-a-chip applications. So it's not even going to be a vending machine anymore with 3D printers. It's just going to be lab-on-a-chip. And I remember reading that was DARPA funded, by the way. As well as, in the not-too-distant future, even micro robots, ding, 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 for biomedical applications, which can grab, transport, and release specific micro objects. Additionally, the researchers could design their artificial molecules so that they can interact with each other and assemble together independently, ding, into larger superstructures. Does this not sound like desktop manufacturing? Because I know it does to me. DARPA has an RFP out there for that very thing called A2P, Atoms 2 products. We're going to look at that one of these days. I think that's still queued up here somewhere. This would, for instance, be relevant for photonics, which, of course, are flashes of light in the mouse brain cells. And I think in that Ad Gene article, they said they actually were selling that little gene package right there to turn mouse brain cells and make them sensitive to optogenetics. Customized microstructures are required in photonics, and this could one day be manufactured with our components. Guys, what a scary, brave new world we are about ready to embark upon. Here's another story. This is out of phys.org as well. Researchers develop not only stuff from Ad Gene, where you can buy for $65 and get the sequence that turns mouse brain cells into ones that are light sensitive, so you could do things like add and remove memories. But now researchers develop synthetic tissue with light activated communications. A team of researchers with Oxford University has developed a type of synthetic tissue made of synthetic cells that are able to communicate with one another. Oh, what a wonderful thing this is. This is beyond horrifying, people. It is happening right before our eyes, under the covers, or maybe behind our backs. But it's out in front of us, and this money is all our money that's going into developing this stuff that none of us have a say in whether or not it's a good idea, or whether or not we want to be a part of the synthetic world we're going to call Earth 2.0. In their paper published in the Journal of Science Advances, the team describes how they developed the tissue by expanding on prior research, how such tissues could be used, and ways that they are looking to improve the material. Scientists have been looking for ways to create synthetic cells and thereby tissues for many years. The idea is that it could be used to replace tissue in living organisms that don't work properly. It could also be used to work with real living tissue to provide new capabilities. Yes, I love Dr. Moreau. And such things as delivery of drugs when needed. And in this new effort, the researchers report on a process that they have developed that allows for the creation of synthetic tissues whose cells are able to communicate with each other via electrical signal in a way that resembles the way that neurons communicate. As the team explains, the tissue is created using what? Oh, a 3D printer. 3D printers. People have been saying democratizes everything. I'm going to say that it is helping us build the destruction of the human race faster than ever before. 3D printers, it prints hundreds of individual synthetic cells, which forms the tissue. In each of the cells is a droplet of water encased in a liquid. And each cell has a bit of DNA in it that has been programmed to react to light. Each cell also has protein pores in it that, when activated by DNA, allows for the passage of ions from one cell to another cell that is physically touching. The result is a synthetic tissue made of synthetic cells that can be caused to communicate with other cells in the same tissue by using a simple light source. And communications can then be controlled by controlling which part of the tissue is exposed to light and when. At the present time, the tissue, of course, is still experimental, though it represents progress in creating truly useful synthetic tissue types. And the team acknowledges that there are still some hurdles to overcome before the tissue could actually be used in applications. And it needs to be altered in some way, for example, to allow synthetic tissue to communicate with real tissues. Oh, yes, to bridge that gap of man and machine. And it also needs to be changed to work in other aqueous environments. The team is also looking to increase the complexity of the tissue to allow for more functionality. It's just, when I see this stuff, guys, we don't even realize how off the rails this is right now, but it is everyone for themselves. The crazier the discovery, the better. The more disruptive it is, the better. And it's all about integrating synthetic with biological so that they can first turn into a parasite and piggyback on biological life and eventually invade biological life like a virus. And that's exactly how they're getting a lot of the synthetic biology and nanobots and things into the bloodstream using DNA nanobots. Sometimes those virus-like particles, synthetic particles that mimic viruses to sneak their ways into cells to release their payload. That's how they're treating some of the new cancers that they're doing clinical testing on, these new technologies. Well, we're running into the last minute of the show here, so I have tons more, but let's hit this one right now, and we'll continue tomorrow where we left off from today. Compact and durable. Scientists encode and retrieve 10,000 gigabytes stored on DNA molecules. Remember, we talked about that DNA storage way back when, and I said I pictured it growing someday as a big Java the Hutt in the NSA data center. Well, they've been working on that. Researchers at the University of Washington and Microsoft, ding, are developing one of the first complete storage systems to house digital data in DNA. The news comes as the digital universe is expected to hit 44 trillion gigabytes by 2020. What? And quote, life has produced this fantastic molecule called DNA that efficiently stores all kinds of information about your genes and the living systems and how they work, and is very, very compact and very durable. So we are now essentially repurposing it to store digital data, pictures, videos, documents in a manageable way for hundreds of thousands of years. All right, guys, well, make sure you stick around because it is Monday. Ms. Lonnie Clark is live. Up next, all kinds of great radio tonight. New Truth on the Tracks, new Al Master News, and live with Nick Burnaby 11. Everyone have an awesome Monday, and I will catch up with you tomorrow. Take care.